Well, before explaining how to solve this question, let me share with you a typical kind of mistake that I've seen in my class. So here we assume that P and Q are continuous functions of t, and we know that y1 and y2 are solutions of the linear differential equation y double prime plus py prime plus q y is 0, right? And then we are assuming that y1 of 2 and y2 of 2 are 0 at the same point in the interval. So what we are given is that y1 at some point t naught equals y2 evaluated at some point t naught equals 0. Now, the typical mistake that I saw is that concluding from here immediately that, okay, so we have two zeros, so therefore y1 and y2 are linearly dependent. So why is this a mistake? Now, it is of course true that two zeros are linearly dependent, but so here, we're dealing with functions for just one value of t, while when we are talking about linear dependence or dependence of functions, then we've got to construct linear combinations that are valid for all values of t. So this is something like, saying that vectors 0, 1, 0 and 0, 0, 1 are linearly dependent because the first entry is of both of them is 0, right? So this is wrong. Okay. Now, this is what I saw in my class. So this is just wrong. Maybe I'll give you a counter example that, for example, maybe something like this: y1 of t is t, and y2 of t is, say, sine t. So both of them turn to 0 at 0, right? So this is an example. So how do we, to prove that the functions are linearly dependent? We've got to use the Wronskian, right? So what we are going to do, we are going to calculate the Wronskian of these two functions, y1 and y2. Generally speaking, the Wronskian is a function of t. So let us evaluate it at the given point, at the point 0. So the formula for the Wronskian is that this is y1 evaluated at t naught, y2 evaluated at t naught, y1 prime evaluated at t naught, y2 prime evaluated at t naught. Now we are given that both values are zeros, so which means that the first row of the Wronskian is 0. So therefore the Wronskian is 0, and now we can indeed conclude that the functions are linearly dependent, because there was a theorem in the lecture that tells us that if the Wronskian is 0 at just one particular point, then the functions are linearly dependent and the Wronskian is constant 0. So then y1 and y2 are indeed linearly dependent. And at the same time, this is not required in the question, but at the same time, it means that the Wronskian would be a constant 0. So the Wronskian evaluated not just at the given point t naught, but at all points is going to be 0.